So how you can purify a substance? It depends on the type of the mixture, the technique which we use to purify a substance. The technique or the method which we will use to purify a substance depends on type of the mixture. First, I will name all the types of the technique and the types of the mixture, and then each technique I will explain in detail. So, example, the first type of a mixture, if you have soluble substance from solution. Soluble, the term soluble refers to something which can dissolve, which refers to soluble. So if you want to separate the soluble substance from solution, so the technique which we can use, there are two ways you can separate. Number one, you can use evaporation. Number two, you can use crystallization. These are the two techniques can be used to separate the soluble substance from solution. Same thing, if you want to separate insoluble substance from solution, each technique I will explain, but first I'm just mentioning the names. So what you can do, you can use filtration, or you can use decanting. So if you want to insoluble substance means a substance which will not dissolve. Example of the first one example, if I need if I want to separate, like example, sodium chloride salt from solution. So if I need sodium chloride salt from aqueous solution, the term aqueous means something which mix in water, we call that as aqueous. So we can use evaporation or we can use crystallization. But if you want to separate insoluble substance from the solution, example, sand from water. So we can use this technique, either we can filter it out or we can use decanting. If you want to separate liquid from the solution or liquid so the technique which we will use, we call that as simple distillation. Example, if you need water from the salt solution. So if we need water from the salt solution, we will use simple distillation. Each technique, I repeat, I will explain each technique. Just I'm mentioning first the type of a mixture, so you have an identification that which technique is suitable, and then each technique we'll discuss. Same way, if you want to separate two miscible liquids, miscible means which can mix with each other, two or more miscible liquids. Liquids from each other. The technique which we use is known as fractional distillation. And if you want to separate two or more immiscible liquid from each other, then the technique which we use is known as fraction separating funnel. Example of two or more miscible liquid, example such as water and alcohol. Water and alcohol are miscible, means they will have one phase when you mix them together. And here immiscible liquid, example oil and water. Oil and water are immiscible liquid. Like example, if you have a container and you add water to oil or oil to water, you will find two different phases. That is called immiscible liquid. The liquids are not able to mix with each other. And if you want to separate gases from each other, so we can use two methods. Either we can use diffusion or fractional distillation. And the last one, if you want to separate colors from each other, or dyes, then the technique which you use is called chromatography. So chromatography is a technique which is used to separate two or more colors from each other. So separating gases, example of separating gases. So you want to separate oxygen and nitrogen from the air. You will use either diffusion or fraction distillation. And here, if you want to separate two color, like example, or identify whether it's pure or impure, you will use chromatography. Like example, blue and green color you want to separate from each other. So these are the techniques which we use. Now we'll discuss each technique in detail. So if you want to separate the soluble substance from solution, we will use either evaporation or crystallization. If you want to separate insoluble substance, we will use either filtration or decanting. If you want to separate the color, if you want to separate two liquid from the solution, we'll use simple distillation. Two or more miscible liquid. Miscible liquid means the liquid which mix with each other, so you cannot identify the position where, like, it appear to be one phase. If you mix water and alcohol together, both are colorless, so it appear to be one phase. So if you want to separate them, we'll use fractional distillation. If you want to separate two or more immiscible liquid which does not mix with each other, we'll use separating funnel. And if you want to separate gases from each other, we can use either diffusion or fractional distillation. And if you want to separate the colors from each other, we will use chromatography. Now, we'll discuss each technique. You can take a screenshot if you want to. So first thing, you have to learn or memorize this table about the salts which are soluble and salts or substance which are soluble and insoluble. If we add water, and substance dissolve, we call that as soluble substance, and solution is known as aqueous solution. So if we add water and the substance dissolve, we call that as a soluble substance, and the solution is known as an aqueous solution. And if we add water and substance does not dissolve, we call that as insoluble substance. So how you will identify which substances are soluble and which substances are insoluble? You have to memorize this table. Number one, all nitrates are soluble. What does it mean, all nitrates are soluble? It means that salts which have NO3 at the last, nitrate salt means which have NO3. So any substance which is having NO3 or nitrate ion, these salts are all soluble. Example, potassium nitrate, sodium nitrate, calcium nitrate, all nitrates, any salt which is having NO3 will always dissolve. Most Chlorides are also soluble. Means most of the salts which have Cl at the last are also soluble or dissolved, except three exceptions are there. You have to learn these exceptions. Three chloride salts are insoluble or does not dissolve, which are silver chloride, AgCl, mercury chloride, HgCl2, and lead chloride, PbCl2. These three chloride salts are insoluble, rest other chlorides are all soluble. So you have to learn this table, like most chlorides are soluble except these three. On the right hand side are, on my right hand side are all insoluble salts. On the on the left hand side, it is soluble. So right hand side is insoluble, left hand side all salts are soluble. So all nitrates are soluble. Most chlorides are also soluble except silver, mercury, and lead. These salts does not dissolve. Same thing, most sulfates are also soluble. The salts which have SO4, known as a sulfate, they will also dissolve. But again, three exceptions. So most salts which have SO4 are also soluble, except three of them, which are barium, calcium, and lead. So barium sulfate, BaSO4, calcium sulfate, CaSO4, and lead sulfate, PbSO4. These are insoluble sulfates. And most of the chlorides, most of the salts which are chloride are insoluble. Most carbonates or chlorides. Most of the carbonates are insoluble. Carbonate means the salt which are having CO3. Does not dissolve except three. What are the three carbonates? Number one, potassium carbonate, sodium carbonate, and ammonium carbonate. These three carbonates are soluble. Potassium carbonate, K2CO3, ammonium carbonate, and sodium carbonate. Sodium carbonate is Na2CO3, and ammonium carbonate is NH4 in a bracket 2CO3. This is a very important table which you have to memorize, because you will use this table a lot of time in different chapters. So salts which dissolve, all nitrates are soluble. Any salt which is having NO3 will dissolve. Most chlorides are also soluble except silver chloride, mercury chloride, and lead chloride. These three chlorides are insoluble. Most sulfates are also soluble except barium, calcium, and lead. And most carbonates are insoluble except potassium carbonate, sodium carbonate, and ammonium carbonate. So take the screenshot for this, and then I will give a question. You have to identify the salt which are soluble and insoluble.
Sir,
Yes.
sir, the compounds on the right hand side, they are insoluble in water only, right?
Yeah, insoluble in water.
Like other solvents, maybe they're
Other,
soluble.
yeah, right. Other solvent, maybe they will dissolve. It will dissolve.
Okay, sir.
But this is only with respect to water. So example, if I say I have, you have to identify the salts which are soluble and insoluble. Send your answers on the group. You can use that table to identify whether a salts are soluble or insoluble. I will write the formula. So NaCl, CaSO4, Na2CO3, sodium carbonate, PbSO4, BaSO4, AgNO3, silver nitrate, MgSO4, and AgCl, number 9, NaNO3, and number 10 is CaCO. So you just have to mention which of them are soluble and which of them are insoluble. You can use the table because you did not memorize yet, so you will use the table to identify the salts which are soluble and the salts which are insoluble. table. Then the techniques which we use to separate these salts. Example, if you want to separate, these are some definitions which you have to learn or memorize. Basic definitions are there. Maybe you have learned before. The solute, the solid which dissolve in a solvent is called solute solvent. The liquid that dissolves in is called a solvent. And the combination or a mixture of solute and solvent is known as the solution. Saturated solution, a solution which contains maximum or much dissolved solute, it can at a particular temperature. We call that as a saturated solution. Soluble, when the solute can dissolve, we call soluble. If it does not dissolve, we call that as insoluble. So these are the definitions which you have to learn or memorize. Take the screenshot, then I will explain. So first, if you want to separate the insoluble solute from the solution, so what we can do, we can either use decanting or we can use filtration. So what happened in a technique of a filtration? So if you want to separate the insoluble solute, so we can either use filtration or we can also use decanting. These are the two methods. So in filtration, what we will do, we will gradually transfer, like we have a mixture and we pass this mixture through a filter paper. So when we pass this mixture through a filter paper, what we will observe, like we have insoluble solid and a liquid, and we pass this through a filter paper. The filter paper will allow the liquid to flow and the solid will left behind or left on the filter paper. So the thing which is left on the filter paper is known as the residue, and the thing which will pass through, that is called filtrate. So what happened, the process of separating an insoluble solute or a solid from a liquid using a fine paper which does not allow solid to pass, and the solid residue will stay in the filter paper or on the filter paper, and the liquid will pass through the filter paper. We call that as filtrate. Is it clear, the technique of filtration? So if a question is explain filtration, you will write this definition. What is decanting? The term decanting refers to gradually transferring the liquid into another container or pouring the liquid into another container. We call this technique as decanting. So here, the same idea. We will have a mixture of, example, a sand and water. So we first allow the sand to settle down. So the sand will settle down. Once the sand will settle down, what we will do, we will gradually transfer the liquid to another container. This process of separating a liquid from a solid, first we allow the solid to settle down, because first when it settles down, then only we can use this technique. So heavier liquid by pouring the solution into another container, and the solid or immiscible heavier liquid will stay at the bottom while the liquid will pour out. What is the advantage of using filtration over decanting? Any idea? What is the advantage of filtration over decanting? Which is more accurate, you think? Filtration is more accurate and same thing, which one is fast? Decanting. So basically, advantage is for using a filtration, it will be accurate. A substance is 100%. A substance is 100% purified when you're doing a filtration as compared to decanting, because you're transferring, so maybe some of the sand particle will also move through the liquid. But the advantage of decanting it is fast, where filtration will take time. But both methods can be used to separate insoluble solid from the mixture or the solution. Then if we want to separate the soluble substance from the solution, so if we want to separate the soluble substance from the solution, what we can do, we can use two techniques. One is called evaporation. So in evaporation, we will take, this is called a china dish. A small dish is there in which we take a small quantity of a solution and we supply a heat energy. When we supply the heat energy, the liquid will escape. So as the liquid will escape, after some time, all the liquid escape, and what we are left with solid, which was dissolved, and we call this technique as evaporation. So separation of a liquid and a dissolved solid by heating the solution, the liquid will evaporate completely and leaving behind the solid. But what is crystallization? Crystallization is a process of forming crystal from the liquid when the solution is concentrated. What does it mean? Example, both techniques we do we evaporate the solution, but the quantity of evaporation is different. Example, you have a container and this container is filled with 10 ml solution and it contains 10 gram of dissolved salt. Okay. So what you will do in crystallization, you will supply the heat energy. So when you supply the heat energy, the liquid will evaporate. But this time you will not evaporate all of the liquid. Example, you evaporated 7 ml of liquid. So how much you are left with? You are left with only 3 ml. So 10 ml can dissolve 10 grams. So 3 ml can only dissolve 3 grams. So what happened? Originally there was 10 gram of soluble or dissolved, but as you reduce the amount of solution, as you reduce the amount of liquid, the liquid now, because of small amount, cannot dissolve too much salt. So as it cannot dissolve too much salt, what we will observe, when the liquid will cool down, so when it will cool down, we'll observe a crystals form. Why these crystals are formed? Because the liquid is not able to dissolve that salt or that 7 gram. That's why the crystals will appear. So this is, in evaporation we remove all of the liquid, but in crystallization we don't remove all of the liquid, a small quantity, or we remove some of the liquid so that the solution become concentrated, and when we cool down the solution, the solid will form. In a hot solution, the solid will not form because a hot solution can dissolve or can have more solute in it as compared to a cold solution. So the steps of crystallization, we will heat it and we'll make a concentrated solution, and then we will cool down. So when we'll cool down, a solid will appear or a crystals will form, and these crystals can be removed by filtration, or you can just take a large scoop and take it out. So the difference between evaporation and crystallization: evaporation, all